Hi, everyone. Hope everyone is okay. Welcome to another Mr. X free class. We are doing mathematics, particular emphasis on Euclidean geometry, grade 12. That is what we're going to be doing. Interestingly, this is me on the right-hand side, Mr. X. Now, who am I? So I am a mathematics and physical science tutor, ranging all the way from grade 10 all the way to grade 12. And I do online classes. That's a lot of what I do. I do physical classes as well. But what I'm known for a lot is the online classes that I do. So these online classes cover both grade 10, 11, and 12 for mathematics and physical sciences. So if you see here, this is your grade 10 era, Mondays, grade 10, and Tuesday for physical science, grade 10. I've got also Monday, mathematics, grade 11, Wednesday, physical science, grade 11. Then for grade 12, it's Tuesdays and Thursdays. So these are 5 lessons that happen per month per subject. So you're looking at 5 lessons per month per subject, and it's 250 per subject. They happen from 7 p.m. up until 9 p.m. every single week. That comes with it. So that's what's going to be happening. So particularly, we have the August-September schedule. This is what you're looking at. Grade 12, what we're going to be learning. Grade 11, what we're going to be learning. Grade 12 maths, grade 12 physical sciences, so forth and so on. Been doing these classes since February, so we're almost, actually, this is our last month of learning that we're going to be doing. The grade 10 classes are pretty new, so tell your friends, your neighbors, your young brothers or young sisters that they can be saved by Mr. X. Also, 250 the grade 10 classes per subject that I'm going to be doing. This is the schedule that we have for August and September, as you can see for yourself. But I'm very excited by what's coming up, which is the prelim revision. Yes, 20 hours. 20 hours of revision. Obviously, not in a full day, broken down into 4 days, 5 hours each day. Now, this is going to be held online, definitely, and it's 500 rands per subject. We're revising every topic that's coming out in the exam. Remember, your prelim exams cover every single topic that is coming out, including what you do in grade 11. Some of the topics in grade 11 come out also as well in grade 12. So all those topics one by one for both mathematics and physical sciences. Obviously, guys, I've got limited space for this, the 20-hour revision program. So if you're interested, there's my number there. Everything that you need to know, you'll be able to get what you need from there on. So 20 hours, about my 20 hours learning one after the other, making sure. Now, traditionally, we do more than 20 hours. We usually end up at about 25 in total because we stretch our lessons to make sure that we cover quite a lot. Very engaging, very interactive, very helpful. Try, make sure these are the ones that I have for both maths and physics. Now, I must admit that there is a problem in the sense that your provinces, you guys come from different places, so the provinces write in different times. So I tried as best to accommodate as many provinces as possible. So that's where I probably failed in that context. Some of you guys are not going to be covered because you're writing a bit earlier. But good news is for the final exams, for the finals, you're all writing at the same time, and I will have classes, revisions for final exams, whether it's mathematics or physical sciences. I have 2 types of revision, which is the face-to-face as well as the online. But keep detailed for that. I will let you guys know what's happening. All right. Having said that, I think I'm ready. I hope you're ready. Let's do this. Euclidean geometry, let's begin. Now, the first theorem that we speak about in Euclidean geometry is known as the proportionality theorem. It's from the perspective that you've got a triangle, A, B, C. This is my triangle. On this triangle, I've got side AB. Let me call it side number 1, side AB. I also have side AC. Let me call it side number 2. Then I have side BC. Let me call it side number 3. As always, 3 sides on a triangle. Now, on AB, on AB, there's a point D. And then on AC, there's a point E. Check the story as we go along with it. So on AB, there's a point D. And also on AC, there's a point E. Fine. There is a line drawn from AB, from the part where there's D, to AC, to the part where there's E. So let's speak maths. There's a line drawn from one side of a triangle, side AB, to the other side of the triangle, side AC. A line drawn from one side of a triangle to the other side of the triangle. That line is DE. Now, notice, you cannot assume that the point D, you cannot assume that the point D is the midpoint of AB. Say that again, say. You cannot assume that the point D is the midpoint of AB. Neither can you assume that the point E is the midpoint of AC. You can't. All we know is that we drew a line from one side of a triangle to the other side of the triangle, from point D to point E. Now, here's the story. Let's build up the theorem. If you are given that DE is parallel to BC, where BC is the third side of the triangle. So the line DE, where is it drawn from? From one side of a triangle to the other side of the triangle. That line DE happens to be parallel to the third side of the triangle BC. If that's the case, then the theorem then says the sides, the other two sides are divided proportionally. Say this again. Theorem, proportionality, theorem. It says to me, a line drawn parallel to one side of a triangle. The line is DE. A line drawn parallel to one side of a triangle, DE, parallel to BC. That line divides the other two sides proportionally. The proportionality theorem. What does that mean when you say you divide the other two sides proportionally? Follow my line of thinking. It means to me AD divided by DB, this side where there is point D, is equal to AE divided by EC, this side where there is point E. Say that again. DE parallel to BC. So DE divides the other two sides in proportion. AD over DB. What you do on one side, you do on the other, is equal to AE over EC. The proportionality theorem. Now, in essence, the proportionality theorem, which is abbreviated as prop theorem when giving your reasons, the proportionality theorem can be used to ensure that any side of a triangle is proportional to the other. So in other words, check this out. If I said AB, check, AB over dB. What would I say on the other side? Work with me. So it's AB, okay, over dB. I need to make sure the other side is also good as well so that I know what's going on. I said A, B, you ever say? Over dB. It means on the other side, I will say AC, thank you, over EC. So with proportionality, the point is what you do on one side is literally what you do on the other. Now, commonly speaking, we usually write it and say AD over DB is equal to AE over EC. Fine. That's all good and well. The prop theorem. Now, obviously, during the course of the lesson, I will teach the theorem, then we do questions on it. Teach the theorem, then do questions on it. Now, every theorem, almost every theorem, has a converse. The converse being the other way of looking into the story. Now, the first one says a line drawn parallel to one side of a triangle divides the other two sides proportionally. That was the prop theorem. In the next one, this is the converse of the prop theorem. In other words, in this context, we are given the sides as proportional already. In other words, we're given that AD over DB, there you are, we're given, is equal to AE over EC. This we are given. Fine. And in that context, the sides are in proportion. So what does the converse say? If a line divides two sides of a triangle in the same proportion, then it means that line is parallel to the third side. So the line DE, by dividing this side and that side in the same proportion, we can then safely conclude that the line DE will be parallel to the third side of the triangle. This being your converse of the proportionality theorem. Now, when it comes to questions in the exam, they come out in different formats. It could be you could be asked about the original one, I mean the first one that I spoke about, or its converse. Point is, you look at the diagram, what do I have? Do I have a line parallel to one side of a triangle? Yes. Then it divides the other two sides in the same proportion. Do I have a line that divides the other two sides in the same proportion? Yes. Then that line is parallel to the third side. Step by step, let's start simple things. Let's start with a simple question. Question number one. So I'll start with simple ones, then we pick up the story over and over again until we fully understand so that we know what we are doing right there. Question number one. In triangle PQR, ST is parallel to QR, okay? Calculate the value of X. I look at a diagram, I see the context. I have a line, ST, yebo, parallel to the third side of a triangle, meaning it divides the other two sides in the same proportion. What am I looking for? The value of X. Let's go. PS statement first over SQ, okay, is equal to PT over TR. So what's important is to start with your statement, then you back it up with the reason. So PS over SQ, I see PS over SQ is equal to PT over TR, and your reason is the prop theorem. Now, it is important when stating the prop theorem to emphasize which lines are in parallel. So from the context of the question, it is ST, which is parallel to QR. Let's put numbers. PS is 5, SQ is 2, is that small, PT, yellow, then UTR is X. You can now cross multiply, and then you can find your X. Cross multiply, 5 times X, 10 times 2, 20. So therefore, at the end of the day, the value of X is 4 centimeters. Statement must be backed by a reason. There must be a reason statement. Reason statement. Reason statement. Let's keep working step by step. We build up and see how far we go on this one. You let me know again where there's a problem, but I'm thinking let's start and build up nicely together as a team. So that's our first one right there. I'm ready for the next one. I'm ready for the next one. Now, again, just to emphasize, you could have done it in either way. Proportionality respects the fact that what you do on the right-hand side or on one side of a triangle is what you do on the other side as well. Either or. So what you do on this side is what you should do on that side. That's what proportionality is all about, as long as there's a line parallel to the other side of the triangle. Question number 2, again, in triangle DEF, let's go. DEF, okay, GH is parallel to EF. I see GH parallel to EF, which means by extension, it divides the other two sides in proportion. Question says to me, calculate the value of M. Statement, reason. Statement, reason. DG, okay, over GE is equal to DH, participate as well. You can be calculating and confirming my answers, over HF. Statement, DG over GE is equal to DH over HF. Reason again is the prop theorem. And we don't forget to put the parallel lines, particularly GH parallel to EF. DG is M. I'm going to put my M right there. GE over 2. DH M plus 2. And then FH is literally your 3. You can then cross multiply. So now it's going to be 3 times M, which is 3M. Then 2 multiplies M plus 2. Algebra, the rest. And we can tell from the value of M, I'm thinking when you transpose M, the value is equal to 4 units. Now, if your values are not given in any other measurement, they don't put centimeters or meters or whatever, you can just write it as units. So DG over GE is equal to DH over FH over HF. And that is your statement, backed up by the reason that says prop theorem while showing the lines that are parallel. Let's up the game a bit. Let's go. Let's go. The more we do, I always tell my students in the online classes that the more you do, hey, the more you know. And the less you do, because yeah, the less you know. All right. Another one. Oh, this one is interesting. Question number 3 is a bit interesting in that aspect. All right, I'm good. Let's go. In triangle ABC, there's my triangle, ABC. DE is parallel to BC. Now, I need to put that on the diagram. They've given me as a statement So I need to make sure that it's cleared up there. DE parallel to BC. AB, the wall of AB, in other words, from here to there is 28 millimeters, while AE to EC is 4:3. Listen to this. AE to EC is 4:3. That's a ratio. Now, it doesn't mean that AE is 4. It doesn't. Neither does it mean that EC is 3. No. But it means by extension, the ratio of AE, whatever the numbers could be, the ratio of AE to EC is a 4:3 ratio. So when writing and labeling them, AE, it's a 4, but it's a ratio. So what we do in maths is when it's a ratio, we put a K. You can even put an X, doesn't matter. And then 3K as well here. So let's go back. It's a ratio, yes. So what does that mean? It means to me, when I look at it, I don't say AE is 4 exactly. When I look at it, I don't say EC is 3, but rather, if by contrast and comparison, the distance of AE to EC will always give me a ratio of 4:3. That's what you do. Okay, all right, say. Uthi AE to EC is not 4, is not 3, but it's 4K, 3K, signifying that K can be any number. Point is the ratio is 4:3. Sure. Calculate the value of BD. They want BD, right. They want BD. I'm looking for the value of BD. Now work with me. Notice that I don't know AD. All I know is AB. In other words, this wall side, this wall length from there to there, I know it. I know AB, but I'm looking for BT. That's what I'm looking for. Let's do the math. Remember what I said to you, that when it comes to proportionality, what you do on one side is what you do on the other. So I'm looking for BD. I would be correct to say, check, BD, what I'm looking for, over AB. Follow me? BD, yebo say, over AB. I'm using what I know to find what I don't know. BD, yebo, over AB. How would I put it this side? You tell me. BD over AB. How would I put it this side? Proportionality. BD is with EC. I see EC, yebo, or over the whole big thing, EC over AC. Reason again is the prop theorem. Back up your reason. Parallel lines, DE parallel to BC. So I'm using what I know, what I'm given, to find what I do not know. All right, I'm ready. So BT, I looking for you. Over AB, I know you. On the other side, EC, proportionality, over AC, work with me. BD, don't know you. AB, I know you. You are 28. They told me. EC, you are 3K. Check. AC, you are 7K. Kanjani, Pru. Kanjani 7. Don't stress. AC, 4K plus 3K is 7K. Sharp. What am I looking for? BD. The rest is algebra. Check. 3k over 7k is 3 over 7. Cross multiply by 28. And in terms of your units, millimeters, BD is now 12 millimeters. There you go. That's my story, and I'm sticking to it. All right, talk to me when there's a problem in that context. Now, it doesn't matter again, because I see someone saying, I did it vice versa. It doesn't matter how you do it on one side and the other side. All you need to know and establish is that there is proportionality. What was done on the left and what was done on the right, what was done on the other side and what was done on the other side will eventually be equal. Notice again, because it's a ratio, these letters, they cancel out. That's why I have 3 over 7 eventually, but they need you to show the presence of that 3k, 4k story, which is basically your ratio from there on. All right, perfect. I'm ready. I'm taking this out. I'm taking this out. It's gone. It's gone. It's going. All right, perfect. Let's keep working step by step. Here's another one. A mixture of Euclidean geometry and his cousin brother, which is trigonometry. By the way, these two topics hold maths together. Literally, they are almost 100 marks. Both these topics, this Euclidean and trigonometry. Here's a question. Let's go. I'm ready. In the figure below, okay, AP, I see you, is equal to sine x. PB is equal to 2AQ is 2 cos x, while QC is equal to 3. Given, stated, and then they said PQ happens to be parallel to BC. Sharp. Question. Calculate the value of x for which x is an element between 0 and 90, greater than 0, greater than or equal to 0, less than or equal to 90. So I'm looking for x. Sine, cos, let's go. So let's do Euclidean first. What do I know? What do I see? PQ parallel to PC. I see that. Sharp. And then from that perspective, it means to me when I'm dealing with Euclidean, I could safely say AP, over PB, okay, is equal to AQ, sharp, over QC. Statement backed by a reason. It's the prop theorem. That's the first one that we've done so far. And acknowledging that PQ is parallel to BC. AP is sine x. PB is 2AQ is 2 cos x, while QC is 3 question, find x. I can cross multiply. 3 sine x is equal to 4 cos x. Cross multiply. Say that again, say. I cross multiply. I cross multiply. What am I looking for? Calculate the value of x. Now listen to this. We've got two ratios, trig now talking. We've got two ratios, one on the left and one on the right. I have a sine and I have a cos. But I'm looking for x. I've got two ratios. So how can we be clever on this? It is possible that I can literally divide both sides by cos x. Say that again, say. I can divide by cos x. Why? Why are we dividing by cos x both sides? I got your back. Because when I divide both sides by cos x, I will change the ratios and have only one ratio. 3 sine x over cos x is 3 tan x. cos x over cos x is 1. So I'm left with 4. Look at it now. We only have one ratio. And what is that ratio? It is tan. Now we can do trigonometry. Divide both sides by 3. So now tan x is 4 over 3. Using your calculator, I've got a video on YouTube on trig equations, so you can check it out. Shift of tan of 4 over 3. Upon confirmation, I'm getting a value of 53.132 decimal places. Now notice one more time, check. What's happening, say? Euclidean happened. Then trigonometry happened. AP, I know you. Over PB, got your back. AQ, I see you. Over QC, okay. Prop theorem. I pick what I see. Sine x over 2, thank you. 2 cos x over 3. Cross multiply. What was the problem? The problem was I had 2 different ratios, a sine and a cos. How do I solve it when I've got 2 different ratios? Then I think to myself, it is possible in all aspects to divide both sides by u cos. In that manner, when I do that, then I divide both sides by cos. Cos is gone. Cos is gone. Left with the 4. Sine x over cos x is the quotient identity. It becomes tan x. Divide by 3. Tan x 4 over 3. Shift of tan. Your value of x as advertised is between 0 and 90, specifically being 53.13. The more we do, because the more we know. Another one. This one, I want to give it to you. Give you a good 3 minutes, 4 minutes on it. Try it, then I pick it up. Then we go to the next theorem after this next question that I'm going to give. Let's see. Flex your muscle. Let's see. Show me your talent. Show me your talent. All right, here's my next question right here, right now. Well, there's my next question. All right, perfect. Question 5, all these. Question 4, the one that I just did, and question 5 are all past exam papers. I just took them and just made them into simple questions. But in essence, I remember question 5, this first one was 6 marks. Then the next one, I think it was 3 marks. Yep, something like this. So you're up on up, 3 minutes. Let's go. You are trying. 3 minutes. Let's go. One more minute. All right, maybe let's try this one together and see if we're going to win. Now, the question, there's keywords to it, which I want us to align to. T, V, R, W. So T, I see you. V, R, yebose, W is a parallelogram. The properties of a parallelogram give me the idea that the opposite sides are parallel. Already, TV is parallel to WR. We can see that. And because the whole shape is a parallelogram, then by extension, TW will be parallel to VR. The properties of a parallelogram. And that's key. I'm ready for that one. Let's think together. So they say to me, PT is x of x plus 2. That's given on the diagram as well. QW is x plus 4. QT, that's 15. And WR is x units. Okay, fine. Question starts. Calculate the value of x. So let's use what we know in order to get what we don't know. Work with me. So the first statement would be to say TW is parallel to VR, and maybe by extension, I could say as well parallel to PR. I will say, why would you say PR? Listen to me. TW, if you look at TW being parallel to VR, VR is on PR. Say that again. TW parallel to VR. Where is VR? It's on the line PR. Fine. So you're saying to us, Uguti, these lines are parallel, and your reason is the properties of a parallelogram. You can write in shortcut or in full, doesn't really matter. I'm ready. What am I looking for? X. So let me see what I can manipulate. Now, let me show you what doesn't work. You can't say PT over TQ is equal to PV over VR because you don't know PV or VR. You don't. But if we use the line TW, then we can now use this portion. Let me show it to you. Let me make sure it's cleared up here. So we can use this part of the triangle, this one that I'm trying to make sure it's a bit clearer. So I can say to myself in that context, I can say QT, follow the proportionality. QT, you ever say? Over TP, is equal to QW, yebo, over WR, and your reason is the prop theorem, and I don't forget to specify the lines that are parallel. I'm dealing with TW W parallel to VR. The rest is algebra. 15 over x plus 2 QW x plus 4 over UX. Then we can cross multiply. Nicely put, algebra at play. When we're doing that, it's going to be 15x. I'm ready. Then x plus 2 multiplied by x plus 4. We cross multiply this side. We cross multiply that side. Open the brackets. Do your algebra pretty well. X squared eventually plus 6x plus 8. All that is equal to 15x. 0, I'm using the quadratic version. You transpose of 15x to the other side. So now in essence, I've got negative 9x plus 8. It's a quadratic equation. You can opt to factorize either by using the quadratic formula or conventional factorization. I see my x. I see my x. I see a minus 8. I see a minus 1. That's my 0. In the context of the story, it means to me the values of x could be either x as 8 or the value of x as 1. These are your answers from there on. Did you get it or not? Did you or did you not? All right, all right, all right, all right. People got it. They are seeing it. They are seeing the light. So remember the context again. Uguti fam, just to repeat the story. Remember, the key for me was the words parallelogram, which then means my shape, whatever it is, has got the opposite sides being parallel. Shuti uti W and UVR, and I can even stretch it, UPR are parallel. So then I said QT over TP, what I do on one side, I do on the other, QW over WR. And in essence, I have my statement backing up with the reason. Then from there on, I can get my X. So you just cross multiply, do your maths, the rest is algebra. So the Euclidean ends here. Then downwards is now algebra in essence. Again, the more we do, the more we know, the less we do, the less we know. All right, let's try 5.2 right here, right now. After this, we go to the next theorem, which is the similar triangles theorem. An interesting one. We go through it and enjoy ourselves as we learn. Maths must be in job. You cannot pass what you don't like. Find love. Find love for maths. You've got to love the subject to pass the subject. Tell yourself you can understand this. Tell yourself I can work and get it. Have confidence to say, listen, I may not understand a couple of things here and there, but if I put in the effort, this will succumb to success. You have no choice but to succeed. Whose problem are you going to be in South Africa if you don't succeed? Whose problem are you going to be? Perfect. All right. I hope you've written this and you open the brackets and you find your X and you get your X is 8 or your X is 1. All right. Let's go to the next one. Let's go to the next one quite quickly. Right there. Now, there's many ways to do this. And let me acknowledge this because I'm seeing other people that did it the other way around. There's no problem. There's many ways to do this. Proportionality speaks the idea that what you do on the one side, you're going to do on the other side as well. All right? What you do on the other side and so forth. Now, somebody's asking, so how do you know which value to use for the following question? Let's see how that goes. So for 5.1, you just write them as they are. 5.2 then specifies which one they want. So 5.1, you just put the both of them and that's it. But for 5.2, they specify if VR is 18, so and x is greater than 1. So if x is greater than 1, which means we're using the value of x as 8. Remember, our value for x was either 1 or 8. And the specification or the restriction for 5.2 says x is greater than 1. So x is 8. What do they want? PV. All right, let's go. I'm ready. I'm ready. So they want this side. PV. So now I can quickly say PV, yeah, we'll say, over VR is equal to PT, okay, over TQ. And your reason again is the prop theorem. And you must specify the parallel lines that we're dealing with, prop theorem. And then you say OTV this time, parallel to WR. So you specify according to what you are literally given right there. So PV over VR, I think PV, don't know. VR given is 18. PT, remember x is 8 from the previous calculation. And I just want to say, when you're finding the value of x from a quadratic equation, you can use the quadratic formula. It's still okay. Or you can use conventional factorization, whichever you're comfy with. All right, PT, x is 8. So I'm thinking PT, 8 plus 2 is 10. TQ being 15. The rest is algebra, cross multiply. 10 over 15 times 18. I'm getting 12 units. And that becomes the value of PV. All right, this was the first theorem that we had today. And let's go to our second one, which is all about similarities. It gets more interesting. Then we do questions along that line as well. And we take it up from there. I'm ready. I'm ready to take this out. The more we do, hey, the more we know. The less we do. The less we know. You do more, you know more. You do less, you know less. Here's one. So, similar triangles. I teach now. Listen to the teaching. So, when you've got two triangles and they are denoted to be similar triangles, the context of similarity is from the idea that if triangles are similar, number one, they have the same exact shape, but their sizes are different. Similar triangles. Well, what do you have? Same shape? Okay. But different sizes. Similarity. Now, the key ingredient to triangles being similar, or rather, when triangles are similar, their angles, matching angles are equal. What do you mean, say? Let me call this triangle number 1, ABC. Let me call this triangle number 2, DEC, sharp. If by any chance, ABC, so I'll write it and say triangle ABC. If by any chance, triangle ABC is similar to triangle DEF. Listen to me. The symbol for similarity is just these 3 strokes. So when you see something like this, it reads to the effect triangle ABC is similar to triangle DEF. If that's the case, then the matching angles are equal. Matching. What do you mean? Matching. Angle A matches with angle D, equal. Matching. Angle B matches with angle E, equal. Matching matching angle C naso equal to angle F matching. So the basis of similarity lies from the idea that the two triangles, the angles in them, the matching angles in them, matching in the context that where A is at the apex is equal to D at the apex, where B is left-hand side is equal to E left-hand side, where C is right-hand side is equal to F right-hand side. The angles match, then the triangles are similar. Check the story. If A, the angle, is equal to D, it's matching. Then B, the angle, is equal to E, it's matching. Then C, the angle, is equal to F, it's matching. Now, mathematically, this is called equiangular. In other words, it shows me that inside the two triangles, the matching angles are equal, equiangular. If we establish that, that the angles, matching angles are equal, then the conclusion is triangle ABC is similar to triangle DEF. All right. One more time. Bring us home. Say, tell us more. Are you saying, if I've got two triangles and I'm dealing with similarity, I must think from the concept, they are similar because their matching angles are equal. So if I'm able to prove, listen to the English, if I'm able to prove that the matching angles are equal, by consequence, it means the triangles are similar. One more time, speak English. If I'm able to prove that the matching angles are equal, consequently, the triangles become similar. One more time. If A is equal to D, yebo. If B matching E are equal, sure. If C is equal to F, now so if they are all equiangular, conclusion, triangles are similar. All right. There's more. Check. Here's what's interesting. Listen to this. So from the previous slide, I'm giving the idea that, well, if you want to prove that triangles are similar, then you've got to show that the angles are equiangular. So I put a statement at the top left corner, and I said to myself, if the two triangles are similar, you must prove that they are equiangular. So here's a hypothetical situation. So I've got two triangles, different shapes, right? Different sizes, but same shape. So I've got a triangle here. It's got 40 degrees matching with this 40 as well. Thank you. I've got another one, which is 80 matching with this 80 as well. So already I know that the two triangles or the two angles in both triangles are equal. In other words, 40 is equal to 40. In other words, 80 is equal to 8. I can see that. I'm given that. Now, if you then want to show that the other silent triangle, I'll call it the third angle of a triangle. If I know that 40 degrees and 80 degrees on one triangle, 40 degrees, 80 degrees on the other triangle are equal. If I know that, then by extension, automatically, this angle has no choice but to be equal to that one. So what are you saying? Once you prove with reasons that two angles in both triangles, two matching angles in both triangles are equal, Then the third one, you don't have to prove it. Now your reason becomes third angle of a triangle. How, say? Why are you confident, Uti, this one is equal to this one? It's because we know. It's because we were taught that all the angles in a triangle, they add up to 180. So if I've got 40 plus 80 added already, this one is now 60. If I've got 40 plus 80 on the other triangle, this one is now 60. So here's the point. When you are proving similarity, and how do you prove similarity? Show that the triangles or the angles are equiangular. If you have shown that two matching angles are equiangular, in other words, you have shown 40 is equal to 40, you have shown 80 is equal to 80, then the last angle, you don't have to stress, we just simply say to ourselves, is the third angle of a triangle. Automatically, it has no choice but to be equal to the other angle in the context of what we do. Fine. This is the background. So what's the theorem say? Say no more. I got your back. Here's the theorem. Equiangular triangles theorem. I'm there on that one there. Now, the equiangular triangle theorem says to me, if two triangles are equiangular, if two triangles are equiangular, then their sides are in proportion, okay, and consequently, the triangles are similar. Say that again. If two triangles are equiangular, okay, then the corresponding sides are in proportion. What do you mean corresponding sides? Listen to me. Triangle number 1, I see you. Triangle number 2, I see you. The two triangles are equiangular. How do I know? One line on A, one line on B, or one line on D, sorry. 2 lines on B, 2 lines on E, 3 on C, 3 on F, just to show you that they are equal. Just basically the idea. In other words, A is equal to D, B is equal to E, C is equal to F. If that's the case, then the sides are in proportion. So if I look at triangle number 1, then I deal with proportional sides. It means AB, that's triangle number 1, goes with DE on triangle number 2. Let's go. AB, you ever say, on DE, over DE. You started in triangle number 1, go back. So I said AB, over DE, thank you, go back, is equal to, I pick this side, AC. Who does AC go with on triangle number 2? Tell me. I pick AC. Come on now. AC. Who does AC go with on triangle number 2? So I pick AC. AC goes over DF. Perfect. Is equal to, go back, BC, or rather right, over EF. Say that again, say. The triangles are equiangular, meaning the sides are in proportion, the triangles are similar. And if they're in proportion, if I start off with triangle number 1, the sides in proportion. Work with me again. AB over DE, go back. Don't remix. I need you started in triangle number 1. Go back. AB, you started. Over DE, go back. AC, you started. Over DF, go back. BC, you started. Over EF. That's what you do. And we usually put a shortcut and say similar triangles in proportion. That's the theorem number 2. Okay, all right. So just to reiterate, then we go deeper on the question. So, say Utiena, if I have two triangles and they are equiangular, then their sides have no choice but to be in proportion, and eventually I am literally on a similarity concept. For every theorem, there's the converse. Here's Bible boy. Converse. I got your back. Listen to me. Here's the converse. The converse says, then we do questions now. I'm excited about the questions. The converse says to me, I've got two triangles, yebo, and if from those two triangles, I'm able to show that the corresponding sides are in proportion. What do you mean? What do you mean? I'm able to show that AB, yebo, over DE, and then I'm able to show that BC over EF, AC over DF, they're in proportion. If the sides of two triangles, if the corresponding sides of two triangles are proportional, then the triangles are equiangular, and again, they are similar. Say that again, the converse. Say it. If the corresponding sides of two triangles are proportional, then the triangles are equiangular, and consequently, they're similar. So in other words, if I'm able to show that I've got that the sides are in proportion, then it means the angles are equal. In other words, the converse is like the other way around, né? Like the other way around. Let's go, boy. Question one, you know we start small. You know we start small, then we'll build up the story. I got your back. In the diagram below, they tell me AB is parallel to DE. So AB is parallel to DE. Earlier on, I'd said that, I think I sent this in the group to say, be wary of concepts from earlier grades. You know, we use them everywhere. So I see parallel lines, so that's going to come handy. AB parallel to DE. Prove that ABC is similar to EDC. Now listen to me, please. Here's my suggestion. You don't have to take it, but here's my suggestion. So you're proving that ABC, so list it. A, B, C. You are proving that is similar, list them. E, D, C. Now let's go. Let's go and look for ABC. So A, this is just A. B, that's just B. Then C, I'm thinking it's C2. So I want to write it down as C2. So you list them. A, B, C. List them. A, B, C. E, D, C. Let's go for E. E is just E on its own. Yeah, we'll say. D is just D on its own. Okay. But C is C1. Prove that they are similar. If I'm proving that they are similar, then I'm showing that the angles are equal. A, I'm ready, equal to E. What's my reason? What's my reason? I need to have a reason for every statement. Why is A equal to C? I got your back. I got your back. So I think that it's because from the parallel lines, I think A is alternate to E. So in other words, I'll say alternate angles. And I must specify the parallel lines A, B, parallel to DE. Let's go for B equal to D. Why is B equal to D? Same idea. It's alternate angles. Your parallel lines is AB parallel to DE. Fine. Then the last one, now hold on. Earlier on I said, all you need to do is just prove the first two. Then the last one, you can say third angle of a triangle. Fine. C2 is equal to C1. I can say third angle of a triangle. I can. Or I can say C1 and C2 are equal because they are vertically opposite angles. So you could have it in this case as third angle of a triangle, or you can say vertically opposite. So notice that we've proved equiangular. Once that's the case, then triangle ABC is now similar to triangle EDC. And your reason is equiangular. If you want, you can say angle, 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 or you can say angle, angle, angle. Doesn't really matter. These are some of the variations that you have when you are showing the essence of similarity. All right, perfect. Somebody says, what about common? No, it's not. It's not common, right? Because C1 is not common, means an angle that is found in the same, in two different triangles. Same angle in two different triangles. That's what common means. So I see that question. C1 is on its own. C2 is also on its own. The reason why they are equal is because they are vertically opposite in that context. All right, I'm ready. The more we do, hey, the more we know. All right, so it's not common because already it's numbered and it's different. I've got a C1, got a C2. Those are two different angles in two different triangles right there. So remember, what do I need to prove? Just prove the first two, or just prove any two. Then the last one, if there's no practical reason, just say third angle of a triangle. All right, perfect. So these are the applicable reasons. You can check your exam guideline. They really want that. Actually, I want to do something similar to this. Okay, let me just skip the next one because I want to do something similar. All right, let's try this one. All right, I'll send you this document. So whatever I've left, you guys will then try on your own. Question number 3, got something interesting on question number 3. So let's go. Remember, we're building up the thoughts that go as far as grade 11. Now, I do have 2 videos on YouTube, where I'm doing grade 11 theorems. So you can check them out, quite decent. So it will help you in all of this. I'm reading. Let's go. In the diagram below, CA is a tangent to the circle. Oh, I love that. CA, tangent. All right, so you are a tangent. Prove with reasons that angle ACD is similar to angle ABC. All right, I'm ready for this one. So write them down. ACD. So I will label A, then C, then D, then ABC, A, B, then C. So let's go back to the diagram and pick who's the A, who's the B, who's the C. Let's go for A, C, D first. A, C, D. So there's A, I see you. C, there's C, there's D. All right, so it's A, C, D. So I'm ready for this part here. A, C, D. So the A is just A on its own. The C is C1. The D is D2. That's A, C, D. A, C, D. All right, perfect. I'm ready. Let's try the other version. A, B, C. Again, we go. A, I see you. There's B. B, I see you. A, B, C. I want to make sure that it comes out nicely. There we go. A, B, C. Oh, right. A, B, C. Hey. I think it's just A on its own complete, and B is B on its own complete. Then C is the whole of C1 and C2. In other words, this is C, the whole of C. Fine. Let's come up with the reasons. A is equal to A, the reason that you love with your soul and your heart and your mind. Come on. There we are. Come on. Or rather right. Or rather right. C1. You C1. Now you C1. Now C1. Now. Why is C1 equal to B? Grade 11. Speak to me. I see a tangent. I see a tangent. C1 is equal to B. Why? Tan-Cot theorem. Check. An angle drawn from the tangent to the chord is equal to the angle subtended by the same chord in the alternate segment. Shortcut. Tan-Cot. theorem. I've already proven 2 of them. The last one, let's run away. Third angle of a triangle. Conclusion, triangle ACD is similar to triangle ABC, angle, or you can say equiangular. All right, perfect. So once you see a tangent and a chord, just know what's coming. You know what's coming. It's the tan chord theorem. So an angle drawn from the tangent of a circle from the tangent to the chord is equal to the angle subtended by the same chord in the alternate segment. Now, if you go to my TikTok page, I was doing this and I was doing it practically with a huge, nice electronic board. So you can see I was talking about the tan chord. I have got all the theorems one by one, nicely put in short videos. So you can also check them on the TikTok page. The TikTok page is Mr. X. Just that. Mr. X. Sounds like the name of a serial killer. Mr. X is in town. 3.2 right here, right now. 3.2 right here, right now. So listen to me. Right there. Now, just to answer a question from someone says, say, on the third angle of a triangle, would I be correct to say sum of angles in a triangle? Answer is yes. Yes, you would be correct. Fine. I'm ready for that one day. Now, somebody says, first time seeing this method, I'm hyped. I got your back. Don't stress. Now, listen to me. Another thing, 3.2. Hear my words. Hear my words very well. Ntwana, the moment you prove similarity, draw the triangles apart. The moment you prove similarity, draw the triangles apart. Hear my words and hear them well. The moment you prove similarity, what do I do? Draw the triangles apart. Here's what. All right, I want to draw them apart because it's easier to handle them when they are apart than just by looking at the diagram. I'm ready. I'm ready. Here we go. So I'm writing A, C, D. Please write them carefully. A, C, D. Then I write A, B, C. Question. Show that CD dot AB is equal to AC dot BC. All right. Show that CD dot AB is equal to AC dot BC. We said if 2 triangles are equiangular, consequently, they are similar, then their sides are in proportion. So let me call this first one triangle number 1. I got triangle number 1 here. I got triangle number 2. So what do they want? CD. Let's go look for CD. There it is. CD over BC. CD, triangle number 1 over BC. Go back. What else do they want? They've got AC. AC is equal to AC. Go back. AC goes with AB. I got your back. AB. What's my reason? Similar triangles in proportion. Go back. Say that again. What's happening? The moment you prove similarity, draw the triangles apart. Easier to handle them when they are apart. Then it says to me, CD, CCD, CD is going with BC. CD over BC. What else do they want? They've got AC. AC goes with AB. Why? Similar triangles in proportion. Then what? Just cross multiply. CD multiplied by AB is equal to AC multiplied by BC. Proven. All right. So word of the day. Once you prove similarity, go back, then use the appropriate proving that they wanted you to do. So So your CD, go back, CD uhamba nobani, BC over is equal to AC. We have AC in the proving. Who does AC go with AB? Then just simple cross multiply. We start small. All right. I got your back. All right. So that becomes your answer in that context. And I'm hoping you're seeing that. So prove similarity, then go back. Prove similarity, then go back. I want to go to past exam papers, crazy ones, because now I've laid down the background. Then maybe some of the stuff, we'll look at it and do it via the past exam papers. All right. Somebody says, let me hear the question. Said, does the arrangement matter? Yes. Oh, yes. Thank you. Let me say this. Let me bring it back. Does the arrangement matter? Yes, it does. If you're going to start with triangle number 1, and it's Utsuena CD over BC, word of the day, go back. AC, you're picking over AB. The reason why I'm picking AC is because I'm also given that. They want me to prove to that extent, so I'm given that, hence I'm picking it. All right, thank you. Someone says, Mr. X got your back. Thank you. I'm fetching distinction. Away. I'm enjoying this. Free things are always nice. But paid things are nicer. Just to remind you, what do? I'm a mathematics and physical science tutor. Speaking of physics, I'm going to be doing a free class on Wednesday. Today is a Monday. So on Wednesday, I'm going to do a free class on chemical equilibrium. It's going to get exciting. So these classes, I do them every month, 250. It's going to be 5 lessons, 2 hours a particular week, 2 hours maths that week, 2 hours physics that week, 5 lessons in total, 250 rands, quality education. Imagine if you are enjoying free things. What about paid things? I will literally be on fire. The fire, more fire. Also, somebody says, Use, just hit us with an ad. Say no more, say no more. And also very excited, I'm going to be having the prelim revision in Lenamara on my 20 hours, 500 rands, 20 hours, all the topics. Also, I'm going to have the finals revision. Be fire on fire. Finals revision are coming as well. I'll give you all the details. But for now, we're focusing on what's happening in the next couple of weeks, which is our prelim exams. And these are the dates, the times, 20 hours in total. And remember, we've only done about, together now, almost 1.5 hours. Imagine what we have learned in 1.5 hours. Imagine 5 hours. Ntwana, save yourself. 500 rands, 20 hours, limited space. I got your back. All right, sharp. The ad is over. Let's go to the next slide. Past exam papers. I'm excited. I hope you are as well. 2022, Free State, June paper 2, question 8.2. 2022, NASA, Free State, June paper 2. Oh, 8.2. 8.2. I got your back. All right, I'm ready. Here we go. Write down the title. Now, this question is quite comprehensive, so I'm going to run through all of it together step by step. And I ask you to ask me where you don't understand. You interact with me, we make it clear, and we take it up from there. Now, I do write documents. I do write a lot of these documents, notes, and all that. So you can get into my classes. You'll be able to get what you need, nothing really hectic. You can get into my groups where I send these documents for free. I don't really charge anything for that because I like you, because I want the best for you. Because I want to make sure that when I get to heaven and God asks me, did you use your talents and your gifts in South Africa? Then I say, yes, Jesus, I did. And then he says, listen, you need to sit next to Moses because you helped the children of South Africa to come for free classes, free 2 hours. Come on now. What you talk about? Here's what boy. 2022, Free State, June, paper 2, question 8.2. Siyafunda. Mahala. Siyafunda. Mahala. I'm ready. In the diagram, ADE is a triangle having BC parallel to ED and AE parallel to GF. All said is also on the diagram. It is also given that AB to BE, that's a ratio, is 1:3. We spoke about ratios in the beginning of our class, and we said AB is not 1. but rather is 1K. BE is not 3, but rather is 3K. Fine. AC is 3 units. EF is 6 units. FD3 and CG is also X units. I'm ready but on that one. All right. 8.21 is 3 marks. Let's start. Calculate, giving reasons, the length of CD. Where's CD? Oh, there. So I need the length of CD. Calculate, giving reasons, the length of CD. So let's use what we know. Now, if I'm going to concentrate on the line BC, now BC, being parallel to ED, then it works. Then I could safely say, because I'm looking for CD, I could safely say to myself, AB over BE is equal to AC, and they gave me AC, over CD, and I don't know what CD is. Fine. So AB, Nailana, over BE, prop theorem, is equal to AC, ICU, over CD. Then the reason is the prop theorem, and my backup is on the fact that the parallel lines are BC parallel to ED. We do maths, we're looking for CD. AB is 1K, they will eventually cancel out. You can say 1X, 1K, I prefer K. BE is 3K, AC is 3, then CD, don't know. The rest is algebra. The K's, they cancel out. I'm left with 1 over 3 is equal to 3 over CD, cross multiply. To find CD, 1 times CD, CD, 3 times 3, 9. So the answer is just 9 units in that case. All right. I'm ready for that one. Okay, perfect. So that's 9 units in that context of CDU. Let me know where the problem is. We start small, then we build up. Now, here's the cruelty of maths. With maths, you've got to get the first one right, because the next one usually depends on the first one, and the next one on the previous one. So once you get 8.21 wrong, 8.22 is wrongest, 8.23 is wronger of wronger, 8.24 is shy. Is shy. You just got onto N3 and you think you will end up in Limpopo. No, that takes you to Durban, boy. That takes you to Durban. All right, sir. So you would have been lost, and nothing flows faster, better, smoothly than wrong answers. Because yeah, you go out of the exam and say, I nailed it. No, it nailed you. It nailed you. 8.22. I'm ready for 8.22 right here, right now. 8.22. I'm ready. Now, they want the value of X on 8.22. I'm ready for value X. I'm thinking value of X is quite interesting. So we got CD as 9. Let's keep it up with the tempo and the energy. I love the people. Love your energy. Love your enthusiasm and so forth. All right. I'm ready. 8.22. Listen to this. X. Now, if I look at the context, CG is that X. Let's be clever and try and, edit our diagram. CD, OCD, the wall of CD is 9. That's the calculation from the previous answer. CD is 9. That means to me, ODG, DG, let me say these letters again. I'm ready. CD, who are you? 9, the previous calculation. Then OCG is X. So OGD, GD must be 9 minus X. What's happening, brother? CD, who are you? I am CG plus GD. CG is X, yebo. CD is 9. And I mean, I'm looking for GD. So GD is 9 minus X. Fine. 9 minus X, that's GD. What are you looking for? I'm looking for X. Now follow my lead. If I try to go back and use BC and ED, I don't think it will work. I'll get a bit stuck. Yes, I will get stuck. So say Utini, if I use BC parallel to ED, nah, it won't work. You can even try it, you'll get stuck. But why can I not use GF? GF, I see GF, there's my GF parallel to AE. Okay, all right. So can I use that? Yes. And if I do that, what am I doing? Listen to me. I can safely say DG, follow me. DG, DG over GA. DG over GA. DG over GA on the flip side is equal to DF, DF over FE. Say that again, say. DG over GA on the other side, DF over FE. What you do on one side, you do on the other, and it's the prop theorem respecting the idea that UGF is parallel to AE. Say that again. Make it clear. Let's see what's happening. All right. I'm taking this out. Follow me. So from the extrapolation that I got prior, I say to you, I need to OCD was 9 from 8.21. Then from 8.22, I'm looking for the value of X. And I said, no, man, if CD is 9, should DG is 9 minus X, which I wrote here. Then I'm using the parallel lines GF and AB to make my life clear. In other words, I'm in this version of things. I'm making my life clear, and I'm saying DG over GA is equal to DF over FE. I write and see if it works. DG is 9 minus X. GA from G to A is X plus 3. Yeah, it is. X plus 3. Literally, X plus 3. I into GA is equal to DF, which is 3, and FE over 6. The rest is algebra. So you pick the story in the context of what it has and what it needs and how you can handle it. I'm ready. We can cross multiply and see how far it goes. So 9 minus X over X plus 3 is equal to 3 over 6. We cross multiply from that context right there. So remember, I was using UGF this time and UAE being parallel. That's why I picked it the way I did. Cross multiply, that's going to be 6 bracket 9 minus X. Cross multiply, that's going to be 3. Then X plus 3, I'm looking for X. 6 times 9, that's 54 minus 6X is equal to 3X, and then plus 9. We do algebra. I'm thinking 9X will transpose to negative 6. Then 54 minus 9 is 45. I divide both sides by 9. Voila, the value of X is 5 units. I got your back. Talk to me now. You pick the appropriate one in the context of the question for what it is. So it really does help if you are able to do that. Somebody says, what if I said dA, dA was dA, the whole of dA, over GD, is equal to, and CG. No, you can't have it from one side. You can't. You've got to have it on two different sides, so that won't work. So when you're doing similarity, remember, you deal with one side and it's similar, and it's proportion, then you deal with the other side and it's proportion. You can't pick proportionality from one side. It's got to be two sides. That's why the theorem says a line drawn from one side of a triangle parallel to the third side divides the other two sides in the same proportion. So 5 units, that's what I got for UX. Pairs well. All right. That's what you have there. Someone says, does it need to be a triangle? Yes. A line drawn from one side of a triangle. Yes. That's the theorem. It works from the perspective of a triangle. Thank you for the question. 8.23. I'm ready. I'm taking this out. 8.23. Now, I want you to hear something and listen to me carefully. This will help you in questions. So I want BC. That's what they want. I want BC. Now, listen to me. I've got the triangle, the big triangle, AED. I've got the big one, AED. Then I've got the small one, which is ABC. Say that again, say. I've got the big boy, AED. Then I've got the small one, ABC. What am I looking for? BC. Now hear me out. If you didn't know, please know this. The triangle AED, I want to write it. Triangle AED. And the triangle inside it, the small one, ABC. They're actually similar. I was saying, Kanjani, bro. How can you look at things and say they're similar? Big boy, AED. Small one inside, ABC. They are similar. How do you know? Maybe let's prove it. So let's list them down when we prove similarity. I'm just showing you an extension of things. You don't have to prove this one in this context, but they are similar. So let's go for it and prove that they are similar in essence. A is equal to A, your best reason in the world, common. E is equal to B. Why say? Why is E equal to B? Look at it. BC parallel to ED. Those are corresponding angles. Seriously? Yeah. Naila, who B? And E. Okay. BC parallel to ED. Those are corresponding angles. Oh, okay. Corresponding angles. Because the line BC is parallel to the line ED. Ah, now I see. Okay. All right. I'm ready. Okay, how about D and E and C rather? Why are they equal? Same idea. C and D are equal because they are also corresponding angles. Or you could have said third angle of a triangle if you want. But I'm just showing you that by looking at the diagram, it is clear that they are similar. Very similar. Third angle of a triangle. Okay, sharp say, siyakuzwa. Third angle of a triangle, siyakuzwa. Then what? You're trying to show similarity, but we're looking for BC. That's what 8.23 means. Yeah, I am looking for BC. So it means, Uguti, triangle AED is similar to triangle ABC because angle, or you can say equiangular. Once we prove similarity, what did I say? Draw the triangles apart. I'm ready. Once you prove similarity, what do? We draw the triangles apart. I'm ready. A, B, C. A, B, C. Sharp. Then A, E, D. The way you put them really matters. A, B, C, A, E, D. There we go. I'll call this triangle number 1, and I'll call this triangle number 2. Why do I have the confidence to separate the triangles? Is because they are similar. And if they are similar, what is the implication? Their sides are in proportion. Okay, let's go. AB, let's try and label what we can. AB is 1K. AC is 3. BC, don't know. AE, I need to, AB is 1K, B is 3K, so AE is 4K. Then AD, oh, that's going to be interesting. AD, remember guys, CD was 9. So AD must be 3 plus 9, which is 12. Then OED, so AD is 12, AD with 12, I get 3 plus 9. Then OED, there's a 6 and a 3, that's also 9. I'm looking for BC, similar triangles in proportion. Similar triangles in proportion. All right. I'm ready. So let's start with our first triangle. What am I looking for? BC. So let's start with BC then. It's in a BC over ED is equal to, go back. You started in triangle number 1, go back. I say to you, go back. BC over ED, go back. I can pick AC because I have all the sides. I can pick AC, boy, over AD. What's my reason? Similar triangles in proportion. We're looking for BC. So you arrange them the way you see, then you pick it up. BC1, don't know. ED 9, AC 3, AD 12. What am I looking for? BC. The more we do, the more we know. The less we do, the less we know. Do the maths. So now I'm looking for BC. Let me bring it home. BC must be 3 over 12 times 9. Do you get 2.25? Is it? Yes or no? I think so. I think so. I think you get 2.25 or 2.25. Either way, it's 2.25. So it's 2.25 units. This is what BC is. You can write it as 9 over 4 as well. Still okay. I don't have a problem with that. It's the same thing anywhere, mathematically speaking. So BC, 3 over 12 times 9. So again, just to reiterate something that never changes and is always the case, fam, small triangle inside is always similar to the big triangle outside where they share parallel lines. Now, one thing you cannot do, and I kept saying this, and this is something I said in the beginning of the video, Uguti, you can't assume midpoint. You see, the midpoint theorem, and I didn't do it here, it's a grade 10 theorem, but it's done also in grade 12. In my revision classes, I'm going to do it. In fact, in my normal classes, I did it already. Then the revision, I'm going to do it as well. So the midpoint theorem is a special case of the prop theorem. But you can't assume just by looking at something with Norman, it's on a midpoint. I feel it in my soul that B is the midpoint. Kanjani, who told you? Why are you feeling? Ufilelani. It can't be like you look at things and assume. Assumption is the mother of all blunders. Can't assume. All right, perfect. So that's what you have right there in that particular context right there. Okay, so BC over ED, AC over AB, and so forth and so on. All right, I'm ready. I'm ready for the next one. All right, I'm taking this out. It's about to go down. I'm on 8.24. 8.24 is connotations of trigonometry. It's about to go down. All right, I'm on 8.24 right here, right now. I'm taking this out. It's gone. Gone. It's gone. It's going. Boom. Now, let me teach a bit and clarify a story. The question says the value of the area of ABC. So I'm going to ABC, area of ABC. Now, what I'm showing you, I have a video on YouTube on it, which is under the topic of sine, cosine, and area rule. Area of ABC over the area of GFD. GFD. Sambango GFD. Let me have it here. GFD. So I want to write it down. And I want to see similarity. If there's something that I can pick up that can work on both triangles. So let me write G, then F, then D. Let me write what I know. AC is 3 already. BC from the previous question is 2.25. This is why I say to you, whatever you did before will be used next. And that's why you need to be very careful. GD, no. Oh, GD, yes. GD was 9 minus X. I remember. And X is 5. So GD must be 4. I'm correct on that. FD is 3. Now, hear me out. The area of a triangle has 2 ways of being found. If I've got a perpendicular line, it's half base times perpendicular height. I don't have a perpendicular height. So we use trigonometry. Now, for starters, angle C here in this first triangle is the same as angle D in the second triangle. Your reason being they are corresponding angles, which we proved earlier. Okay, sharp, grand lap. So angle C and angle D are equal, but I'm looking for area. Area. So when you're looking for the area of a triangle and you've got the following information, I've got a side and an angle in between. Come on now. I've got a side also. I've got a side and what else? An angle in between. Yeah, we'll say side, angle in between. Then the area rule says to me, area of triangle ABC over area of triangle GFD is equal to, let's go, half bani, the side, what's the side? AC, I'm on the first triangle, times the side bani, BC, times what? Times sine of the angle in between. Say that again, which isn't here, which isn't here. If I've got 2 sides and an angle in between, I can get the area. Half AC times BC times sine of the angle in between. I got your back. Look for the next one. The next one, triangle number 2. I need 2 sides and a given angle. 2 sides and a given angle. I'm ready. So it's going to be half. Naso. GD. I've got a side. Times FD. I've got a side. Times sine D. It's called the area rule. Half of one side times half of the other side and the angle in between them. Let's put numbers and see if it works. AC, you are 3. BC, you are 2.25. Okay. Sine C, I don't even know what C is. I don't, but it's fine. Then over, I'm ready. Half. GD, you are 4. FD, no, GD, yes, you are 4. FD, you are 3. Times sine D. But say, But say, tell us some more. We don't know what C is. We don't know what D is. Yes, we don't. But one thing for sure, one thing for shizzle and nizzle is that C and D are equal. Why is C and D the same? Because they are corresponding. So it's like they cancel out. What's my answer? I need a ratio. I need a value. You tell me, put the numbers in the calculator, because the more we do, the more we know, the less we do, but the less we know. All right, talk to me now. What you get as an answer, I think I get 9/16, personally speaking. All right, so my answer is 9/16. Pairs well, boy. Pairs well. All right. And then we get that part, and I'm good to go. All right. 9/16. I'm ready. Let's do our last question we got with the bank, because last I checked, the more we did, the more we knew. And the less we did, the less we knew. All right. I think everyone's understanding. I hope. I hope you can always ask, as always. You are free. You can join also my WhatsApp groups, whereby I send a lot of notes, documents, videos. Check out this what bani. Someone says, I'm so sad, it's almost ending. Yes, just like any relationship, it's not you, it's me. You deserve better. Hey, abafana. All right. I'm ready for the next one. It's not you, it's me. That's why it's ending. You are a wonderful person, and I will miss you dearly. Let's try our next one quickly. I'm ready. 2016 Eastern Cape right here, right now. 2016 Eastern Cape right here, right now. All right, Chuck Norris, let's go. Let's go, Chuck Norris. Given, I want you to write the title. This is a very interesting question. We work it out on that one. All right, right there. Somebody says, "Sir, I was lost when you said sine C cancel sine D." Okay, no, don't stress. Let me go back a bit just to clarify that. The reason why I said sine C and sine D cancel is because I said C and D are the same. Imagine if this was 20 and this is 20 degrees. So it will be sine 20 over sine 20. This C and D are the same. So they will eventually cancel out. So that's the idea behind that question. All right, I'm on 2016 Eastern Cape, June paper 2, question number 11. We are up on it. Let's go. Given O is the center of the circle, BA is perpendicular to AC, and the point D is the midpoint of BC. So what is important in every question is to be able to look at the keywords from the context of the diagram. D is a midpoint. Now D1, it's a midpoint of BC. So I see D, who are you? I'm a midpoint of BC. I've got a circle, I've got a center, and end. 11.1, we start. Prove that ABC is similar to DOC. So I need to go for that part. And I said earlier on, list them down. A, B, C. And then we've got D, O, C. Just list them down. I'm okay with that. You're just listing them down. Okay, sharps, grand lap. So let's go look for who is who and what is what. Now, A is 90 degrees. So let's go for A. So it's A, B, C. Let me go for A. This is A, all of A, B, the whole of B, C, the whole of C. That's fine. Then for DOC, let's go and confirm DOC. DOC, I think it's D2O, O3. So D2, then O3, then C. All right, let's start with our reasons. Let's start with the first one. I think C is equal to C. It's common. I need another one, then the other one the last one becomes the third angle of a triangle. Let me confirm something. So if I look at this, A is 90 degrees. This I am given. So say A 90, yeah. Manje, why is D2 also 90? Because if A is 90, then D2 must be 90. Why is D2 90? Grade 11, welcome. A line drawn from the center of the circle to the midpoint of a chord is perpendicular to the chord. I'm ready. A line drawn from the center of the circle to the midpoint of the chord is perpendicular to the chord. Oh, so D2 becomes 90 degrees because of line from center to midpoint of chord. Yes, that's what it becomes. So D2 is 90, and so therefore A is equal to D2, and from the reasons at the bottom, I can see that both are equal to 90 degrees. 2 reasons spotted. Last one, third angle of a triangle. Conclusion, triangle ABC, is similar to triangle DOC, equiangular, angle, angle, angle. That becomes the story as you see it right there. Last I checked, the more we did, the more we knew. The less we did, the less we knew. Hey, all right. I'm ready. All right. So that's ABC being similar to DOC. So again, just to clarify, let's go back. What is saying? Me, personally. Me, myself, and I. I'm saying, why don't you list down the angles, ABC, then DOC also properly. Then from there on, you go to the triangle. Pick your A, it's just A on its own, your B on its own, your C on its own, DOC, D-O-C, D2, O3, and C. D2 is 90, much as A is 90. Why is D2 90? Line from center of the circle to the midpoint of the chord is perpendicular to the chord. So D2 is 90, and even D1 is 90. Then A is 90 because we're given. So this is our first one, common. Then the last one, the third angle of a triangle. Then the angles or the triangles are now similar in that case. I'm ready for 11.2. The more we do, the more we know. Make sure that you live by that motto. Make sure that you know that. There's no miracle to passing. He who works hard will pass equally as well. You've got to put yourself for school. You've got to dedicate yourself for this thing. You need this. You're not going to be a DJ winner. And you're not going to be an influencer. Okay? You can't live your life looking for likes. Every day you're playing video games on TikTok there. Yeah. Touch the screen, Gaban. Touch the A, touch the D2, touch the APC. Funan lap. Go, yes, thank you for the rose. Thank you for the rose, Gabani. Funda. Learn. Get educated. No staff, Baba. Touch the screen, Subong. Slowly, Nana, touch the screen. Oh, 11.2, and you're not going to be a prophet as well. Yar. I'm ready for 11.2 right here, right now. 11.2 right here, right now. So 11.2, the moment you prove similarity, fam, draw the triangles apart, and we can pick it up from that perspective. So I'm ready for this. So you draw the triangles. I'm drawing the triangles. A, B, C, which happens to be similar to DOC. All right, sharp. I want ABC. Where's ABC? A, B, and C. Then I've got DOC, D. I write it the way it matches. D, and then O, then C. Actually, if you think about it, the way they are written, A is going with D. B in the center with O in the center. C at the end with C at the end. So that's how it's written. Triangle 1, triangle 2, what am I looking for? I'm looking for to show that OC is DC dot BC over AC. 1 mark. Okay, sharp. So there's OC. Now OC is in triangle number 2. OC goes with who? Goes with BC. I even see that they've got BC. Let me see what else they have. They have DC. Now DC. Who does DC go with? It goes with AC. Let's start with triangle number 2. Let's start with triangle number 2. It's still okay. So in triangle number 2, I'll say OC. OC over BC. Go back. Go back. OC over BC. Go back. Go back is equal to DC. You ever say? I need you've gone back over AC. What's my reason? What's my reason? Is similar triangles that are in proportion. Then you want to look for OC. So why don't you just cross multiply? Now it's going to be DC dot BC. You cross multiply dot BC over AC. Just 1 mark is fine. So I've shown the similarity and I've given the triangles and then picked the sides according to what I know. All right. So remember, the moment you prove similarity, please go and draw the triangles apart, especially on the question that say, hey, ban, OC, BC, ban. So you'll be able to get that right. So I picked triangle number 2 and say OC over BC. Go back, DC. You pick what they wanted you to use. 11.3. I'm ready for 11.3. 11.3. We're going to be doing massive revisions for the prelims, massive revisions for the finals. Is going to go down. OC. All right, I'm ready. I'm looking for OC on 11.3. I'm taking this out. I'm reading the question for what it is. The question then says, okay, let me take this out and then put this back because I need this. The question then says, given that DC is 15 centimeters. Where's DC? Where's my DC? I see DC. DC Comics is 15. Now DC, this is a D. DC is 15. AB is 18. Now AB Wami is 18. Calculate the length of OC rounded off to 1 decimal unit. Okay, but for OC. So last I checked, OC was DC multiplied by BC over AC. Now let's see what I have and what I don't have. I'm looking for OC. I don't have you. DC checklist, I have you. BC, no, I don't have you. AC, no, I don't have you. Okay. Exactly, man. All right. But let's see what we can do. Now, for starters, DC is 15. So let's go back to the original diagram. DC is 15. So if D is a midpoint, surely BC must be 30. And it's, yeah, if I look at the original diagram, what DC of 15? Yeah, say. So BC is twice as much. So BC must be 30 units. So BC, I have you. At least I have you now, because BC with 30. Checklist, BC I have. AC, give me the problems, man. They're giving me heart palpitations, AC. But let me go back to the original diagram. Do not be afraid, because why? You can do this. You can make it. AC. Look at this triangle and let's pick up the story. AC. I see a theorem. What theorem do you see that I see? What theorem do you see that I see? What can I do that you see I can do? Because Lana AB is 18. AC, don't know. BC is 30. What theorem do you see that I see? Pythagoras. Yeah, well. So in the original diagram, if I look at triangle ABC, in the original diagram, I can use Pythagoras theorem to find AC. So I can say BC squared is equal to AC squared plus AB squared. What's my reason? Pythag. BC with 30 yellow. AC, don't know. Don't know. AB is 18. That's 18 squared. Can I please have AC? AC band. I'm looking for AC. I'm getting AC. I get 24. Do you get 24? I'm getting after square rooting. I get AC as 24. Thank you. So it's 24 centimeters. So now I have AC. DC, BC, AC, I have you. And what am I looking for right here? I'm looking for OC. 9. OC is equal to DC. DC or 15. 15. BC or 30. 30. Over AC is 24. 24. They say it's to 1 decimal place. Maths in the house. Right here, right now. 18,8 centimeters. Right there. Danko Poza. Asbon. Guys, been amazing as always. Thank you so much for joining the class. I cannot wait to teach you in the normal good classes that we're going to do. Remember the classes that I'm going to be having. I have these monthly classes for grade 10 up to grade 12. And we are doing all the topics. And actually, I'm going to be done with the syllabus quite soon. I've been doing these classes since February. Yo, the people are winning there. People are getting a much distinction. You see, maths must be fun. While you learn, you don't even feel like you're learning. A bulk of you are enjoying and laughing and all that. Free lesson, free comedy. But at the end of the day, we're learning. And that's the beauty of school. It doesn't look like it's work. The moment it's now becoming too much of work, maybe we're doing it the wrong way. But here we are. I want you to know that you can pass. I know maths and physical sciences look tower as those type of topics that are like, yo, so difficult. I can't. But yes, you can. Yes, you can. Yes, you will. You will pass by fire, by force, but mostly by force. That's how you're going to pass. By fire, by force, but mostly in all essence by force. Thank you so much. I see your messages of thank you, sir. Thank you, sir. You're welcome. Anytime, I got your back. So just to summarize the story, I'm going to take this out now quickly. Just to summarize the story, who am I? I am that guy that can save you. Yebo, Chuck Norris. Nazo. What do? I teach mathematics and physical sciences, grade 10 to grade 12. I'm going to be holding, or I hold monthly classes for $250 per month, 5 lessons, 7 p.m. to 9 p.m. Maths is Tuesdays for grade 12s, and physical sciences is Thursdays. These are the topics that I have for August, which is my last month of teaching, because I've been teaching this since February. If you started knowing about me right now, where have you been, Chuck Norris? Who have you been looking into? Then from there on, I'm going to be having the big boys, which are the prelim revisions, but the biggest of them all is going to be the finals revisions. The final revisions has 2 versions. There's the face-to-face version. Then there is the online version. I'll give you all the details. Those that are not in my WhatsApp group, say no more. Say no more. My number is also on the screen right there. You can always take it up, and I can write it down as well so that you can be able to get whatever you need. So you can check it out in the posters and all. Some of you are joining because of your friends. Some of you joined just to see and understand, or curiosity. I hope you learned. I might not have touched on everything, but for a free class, I think we did a decent job. Thank you. I'm going to stop the recording right here, right now. Those on YouTube, love you guys, and thank you so much. And those who want to come into the WhatsApp groups, like I said again, check, and see for what it is right here, right now.